Karen Hunger Parshall. She's Commonwealth Professor Emeritus from the University of Virginia. Unique, so far as I know, is having positions in both the departments of history and mathematics. And today, Karen is going to be talking about Toward a History of Mathematics in the United States.
Thanks, Joe. Can everybody hear me? In the back? Is it okay? Okay. So first, I'd really like to thank all the organizers, Adrian, June, Chris, Troy, and I'd also like to thank the Isaac Newton Institute for its hospitality and for allowing us to all be here together. It's, as all of my predecessors up here at the podium have said, it's a wonderful place and this has been a wonderful opportunity. All right, so let me try to address this, and I totally echo Tina, this very difficult assignment that we had as speakers. Took me the longest time to decide what I was going to speak on today. So let me get going. In 1985, historians of American science, Sally Kolstad and Margaret Rossiter, brought together a group of their colleagues to confront essentially the same question that we've been asked to consider here this week, albeit in a different context. We've been asked to think about emerging themes in the modern history of mathematics, that is, in the history of mathematics as it's being done today by us and others. While Kolstad and Rossiter's collaborators were, quote, to assess the current state of various specialties in the history of American mathematics and to indicate what needs and opportunities remained after more than a decade of significant activity. The latter initiative resulted in the book, Historical Writing on American Science, Perspectives and Prospects, the first volume in a new series of Osiris that was brought out under the auspices of the History of Science Society. Indeed, Arnold Thackeray, the then editor of the HSS's journal ISIS, declared that, quote, it was natural to make American science the theme for Volume 1, since, as he saw it at that moment, quote, within the history of science, scholarship on American science was the leading sector. So this is 1985. Historical Writing on American Science brought together 15 scholars who looked at what they delineated as 4 different aspects of their field. There were the so-called classic themes, their term, of American science, namely institutional history, as well as science in medicine, science in religion, and science in the federal government. There were also the newer areas, again, their term, of native knowledge in the Americas, science and technology, science and war, and post-World War II science and public policy. And then there were issues of access to sources in addition to what they called science in the specialties. So the specialties that they covered represented basically a tour of the science quadrant of any U.S. university in the 1890s. Astronomy, biology, chemistry, geology, and physics, together with the social sciences. But you might have noticed a glaring omission there. There was no mathematics in this volume. So what were the readers of this book supposed to take away from that, if indeed they even noticed it at all? Was there effectively no history of American mathematics to survey and assess in 1985? Were historians of American science active within the History of Science Society in the early 1980s simply focused elsewhere? Or was something else at play? Leaving aside possible answers to those questions, suffice it to say that a significant amount of ink has been devoted to what had evolved by the 1960s, thanks to the social and cultural turns in historical scholarship, as the fraught relationship between the history of science and the history of mathematics. Prior to that time, historians of science confidently followed the founder of their field, George Sarton, in the much-quoted belief he expressed in his 1937 book, The Study of the History of Mathematics, namely, take the mathematical developments out of the history of science and you suppress the skeleton that supported and kept together the rest. It's mathematics, he held, that gives to science its innermost unity and cohesion. After the mid-20th century, though, with the increasing emphasis on so-called external as opposed to internal factors in the development of science, the strength of this position quickly eroded. As recently as 2011, ISIS carried a focus section entitled The History of Science and the History of Mathematics, in which historian of mathematics Amir Alexander argued that the answer to the question, should historians of science care about the history of mathematics, is, in his word, yes, and unequivocally so. His co-contributors to this focus section, Moritz Epple, Stephanie Dick, Joan Richards, Jeremy Gray, and Tony Mann, each in their own ways, concurred, even if Jeremy closed on a cautionary note that we have a lot to do, i.e. we historians of mathematics. But in many regards, the relationship between mathematics and the history of mathematics is also fraught. That was brought out quite starkly by the ever-blunt mathematician André Weil in both his blistering review of Michael Mahoney's biography of Pierre de Fermat in the Bulletin of the American Mathematical Society in 1973, and then again when he took the podium at the International Congress of Mathematicians in Helsinki in 1978. Invited to give an hour-long plenary address, Weil opted to speak not on some aspect of the mathematics that he had helped to develop, say in number theory or algebraic geometry, but rather on history of mathematics, how and why, or why and how. Have it how and why there, and why and how in my notes, so I don't know. I'll have to check. Of course, this was another area in which Weil had done a certain amount of work, and in his ICM lecture, he stated unequivocally that, quote, "The craft of mathematical history can best be practiced by those of us who are or have been active mathematicians, or at least who are in close contact with active mathematicians." For Weil, such things as gaining insights into a great mathematician's character and into his weaknesses is an innocent pleasure that even serious historians need not deny themselves. There was only one valuable, one right history of mathematics for Weil. And he even used a different term for it, mathematical history. If he talks about history of mathematics, that's something else for him. That's sort of squishy. Mathematical history, that's the real thing. So that was the type of history of mathematics done by the collective Nicolas Bourbaki, of whom Weil was a part. The type of history that, for example, properly, in Weil's words, analyzed the contents of books 5 and 7 of Euclid, using the concept of group and even that of groups with operators, since the ratios of magnitudes are treated as a multiplicative group operating on the additive group of magnitudes themselves. For Weil and his fellow Bourbakistes, what makes the history of mathematics interesting is precisely the early occurrence of concepts and methods destined to emerge only later into the conscious mind of mathematicians. It was also interesting, as Weil suggested, because it treated the work of great men. Well, the historian would take issue with Weil's premises. The kind of technical history of mathematics that Weil espoused, the historian would say, is ahistorical. The historical figures did not have the advantages of modern constructs, so they couldn't have understood things in those terms, even if those terms are congenial to the modern mathematician. How then, the historian would ask, did they understand things? And who were they? Are only those identified as great, either in their own day or only subsequently, important in the development of a set of mathematical ideas? Or put another way, what the historian would ask are the dynamics of and who constitutes, what the historian would ask are, what are the dynamics of and who constitutes a mathematical community? So putting it polemically, as was his, or as could be his wont, the distinguished and much lamented English historian of mathematics, Ivor Grattan Guinness, summed things up this way in 1990. The history of mathematics is a classic example of a ghetto subject, too mathematical for historians and too historical for mathematicians. So with this broad and complex historiographical framework in mind, let me tackle the problem at hand, this evil problem that Adrian assigned us, historiographically. That is, let me see if a glimpse at the historiography of mathematics in the United States can lead us to an answer to the question, what is the most important question or lacuna in the history of American mathematics now? So let's start with a look at the historiography of mathematics in the United States up to 1989. That is, to the year in which the American Mathematical Society published its three centennial volumes. So regardless of the reason why historical writing on American science lacked a chapter on the history of mathematics, Ute Merzbach filled that unfortunate gap just 4 years later after the volume's publication. In an article called The Study of the History of Mathematics in America, a Centennial Sketch, published in the AMS Centenary volumes, she demonstrated that historical writing on American mathematics went back at least to the 19th century in America with the publication in 1890 of The Teaching and History of Mathematics in the United States by Swiss emigre mathematician Florian Cajori. His book also marked, in a sense, the beginning of the study of the history of American mathematics per se. In it, Cajori presented what was effectively an institutional history of mathematics in the United States up to 1890, as well as a snapshot of both the teaching and research activity then underway in the country. As he saw it, the mathematical developments had thus far passed through two developmental stages. First, a period of British influence lasted until roughly 1820 and found American mathematics teaching dominated by British or British-inspired texts, and the American mathematics curriculum following that of most British institutions. Second, an analogous period of French influence persisted, in his view, to the present time, that is, to the 1880s. His analysis of each period proceeded school by school with a clear focus on programs in the eastern half of the country, despite the existence of universities west of the Mississippi, that is, the other half of the country. In all, he highlighted 22 programs. And while subsequent scholarship has taken issue with his rather simplistic interpretation, and we'll talk more about that in a minute, his study remains remarkable for the comparative data, flawed and incomplete though they may be, that he amassed on the state of mathematics at some 168 colleges and universities in the United States around 1890. It is remarkable for that. So a tradition of work in the history of mathematics in general, but also in the history of American mathematics per se, continued into and through the opening decades of the 20th century. To abstract out the two major book-length examples of the latter from the many, many works that Merzbach highlighted in her essay, we find A History of Mathematics in America Before 1900, published in 1934 by historians of mathematics David Eugene Smith and Jekuthiel Ginsburg, and a semi-centennial History of the American Mathematical Society, produced 4 years later by mathematician Raymond C. Archibald. While the first of these two books covered much the same ground that Cajori's had, it was a work more reflective of genuine historical research as opposed to a compilation of data. The second broke new ground in documenting the history of the country's first professional mathematical research society. So Smith and Ginsburg, unlike Cajori, aimed at a connected narrative of the historical development of American mathematics from the earliest explorations of North America in the 16th century through 1900. They situated their story both within its cultural and institutional context through what Smith described as a painstaking examination of material in several of our largest libraries. Like Cajori, though, they were interested in making their readers aware of those who had come before, and not just those with what they termed prominent names, their term, but also those whose names were less well known. And whereas Cajori focused primarily on the teaching side of the mathematical endeavor, Smith and Ginsberg, while not neglecting that, tried also to give a non-technical, bibliographical sense of what they called the general trend of mathematics in America and the trend of important branches of American mathematical research, especially in the last quarter of the 19th century. From a methodological point of view, Archibald's book was quite different. It represented a deep dive into the archival record as held by both longtime AMS secretary, his colleague at Brown University, Roland Richardson, and by various of the Society's past presidents. It documented the AMS's founding, its incorporation, the vagaries of its funding, the different initiatives it championed, its publications, its political structure, and its various offices and officers. Relative to the latter, it also provided biographies of those who had served as secretary and president, as well as bibliographies of their works published to 1938. For these reasons, it remains an invaluable secondary source for historians of American mathematics almost 90 years after its publication. Moreover, although Merzbach didn't mention it, Archibald's book was accompanied by a second volume of semi-centennial addresses of the American Mathematical Society, the aim of which was, quote, to serve both to reveal what has been accomplished in America since the founding of the Society, and also to acquaint mathematicians with current problems and research in many fields. 8 of the leading mathematicians in the country at the time contextualized technical American contributions in algebra, algebraic aspects of the theory of differential equations, harmonic analysis, the calculus of variations, geometry, topology, the Dirichlet problems, and hydrodynamical stability, while George Birkhoff, arguably one of America's best known and most renowned mathematicians, took on what he described as, quote, the challenging task of tracing our mathematical development under the auspices of the Society during the years which have passed. That is, the 50 years from 1888 to 1938. These expository essays represent a concerted effort on the part of mathematicians to establish the respective mathematical contexts of their topics, to address the mathematics itself in a technical way, but also in a historically sensitive way, and to highlight not just the great men necessarily, but American contributors. In so doing, they provide meaningful looks into some of the technical aspects of American mathematics over the course of the AMS's first 50 years, without, for the most part, reducing their accounts to the kind of ahistorical approach they would later advocate. So clearly, anniversaries are often causes for retrospection, and 2 more prompted new books on the history of American mathematics. In 1977, the Mathematical Association of America, the country's leading teaching-oriented professional society, brought out the bicentennial tribute to American mathematics, 1776 to 1976, an edited volume that, in celebrating the nation's 200th birthday, called on mathematicians, historians of mathematics, and mathematics educators to take yet another retrospective, albeit this time fairly superficial, look at mathematical developments in the United States. Since fully half of this just over 200-page book dealt with mathematics teaching per se, space in it for the history of American mathematics was limited. Still, there were brief essays on mathematics in colonial America, and the American mathematical scene from 1776 to 1876. There was also a longer, largely potted biographical compilation on, this is the title, Leaders in American Mathematics, 1891 to 1941. There were also 3 short focused studies on mathematics and the federal government in the post-World War II era, on the history of computing, and on the bombs, Sputnik, and European mathematicians. That was the title of that one. And there was also a more technically oriented overview that aimed in 20 pages, quote, to describe some major victories of American mathematicians since, or since more up to the present day, 1976, and to mention the names of the winners with enough explanation, but just to show who the enemy was. So the terminology there is noteworthy. For some of the contributors to the volume, at least, the history of American mathematics was about leaders, victories, and winners. Another anniversary, this one, the centennial of the founding of the American Mathematical Society in 1988, prompted the much more substantial, much more widely ranging 3-volume work, A Century of Mathematics in America, in which Merzbach's essay appeared. An impressive undertaking of well over 1,700 pages, it reflected many aspects, technical, institutional, biographical, social, of the mathematical endeavor in the United States in the form of new scholarship, personal reminiscences, and reprinted sources collected together from disparate publications. From a technical point of view, it singled out the broad areas of topology, logic, differential geometry, applied mathematics, algebraic number theory, probability, and analysis, in addition to more specialized topics like the classification of the finite simple groups, category theory, and intersection homology theory. Among the educational institutions it highlighted were the following long list: Berkeley, Chicago, Columbia, Harvard, the Institute for Advanced Study, Johns Hopkins, MIT, Michigan, NYU, Princeton, Stanford, Texas, and Yale. Biographical essays and/or personal reminiscences of selected leaders in the field, male, female, and African American, put human faces on the more elite members of the research community, while more overarching historical essays treated themes like the formation of an American mathematical research community in the last quarter of the 19th century, mathematicians in wartime, the emigration of foreign mathematicians to the US, especially in the 1930s and 1940s, and the effects of the Red Scare of the 1950s on American mathematics. So a closer look at the bicentennial and semi-centennial volumes suggests, in fact, a historiographic analysis for the history of American mathematics analogous to that of Kolstad and Rossiter for the history of American science writ large. There were the classical themes of the technical history of mathematical developments, institutional history, biography, and the history of mathematics teaching. There were the newer areas of the cultural history of American mathematics and the history of American mathematical developments after 1950. And finally, there were primary specializations in the 19th century as well as in the first half of the 20th century. Indeed, from a historiographical point of view, many of the contributions to these volumes suggested extended studies, and whether or not they directly inspired such work, it wasn't long after the publication of these 3 centennial volumes that it began to appear. So let's briefly now consider 3 books and a website that echoed themes, key themes, from these volumes, and in so doing, take our historiographical survey of American mathematics from 1989 to roughly the present. One study that was directly inspired by the AMS Centennial is probably the main reason I'm standing up here talking to you today. When Peter Duran and Ed Edwards, 2 of the editors of the Centennial volumes, approached David Rowe and me to contribute to their publications, we were presented with a unique opportunity. We'd been discussing how interesting it was that our respective research seemed to go far to account for the rise of the American mathematical research community in the last quarter of the 19th century. David's focused on Felix Klein and his work and students in Germany. Mine centered largely on the US, and in particular on James Joseph Sylvester's animation at Johns Hopkins of what can be thought of as the first school of mathematical research in the United States, and on the role of E.H. Moore in establishing and building the Department of Mathematics at the University of Chicago. When we sat down to produce our chapter, which we called American Mathematics Comes of Age, 1875 to 1900 for Peter and Ed, we realized that we were essentially writing a narrative outline of a book on that topic. So we just decided to go for it, but we really didn't know, I don't think, what we were getting ourselves into. So as I sketched earlier, we were venturing into a complex historiographical ecosystem made up of the history of science, mathematics, and the history of mathematics. As we put it in the preface of our book, The Emergence of the American Mathematical Research Community, more than the ideas involved in the pivotal scientific discipline of mathematics merit historical illumination, and approaches other than the standard internalist techniques will be required to confront its diverse historical issues. So we consciously sought to meld, again, what were then called internalist and externalist techniques in describing an emergence of research-level mathematics in the US as the result of the independent efforts of 3 mathematicians, 1 English, 1 German, and 1 American, on 2 continents, North America and Europe. As we argued, it was a surprising confluence of historical trends and events that enabled this disparate trio to emerge as the dominant figures in the story. Moreover, by analyzing their actual mathematical research in their respective institutional and cultural contexts, we showed how they inspired the subsequent work of many of their students and of those students' students. In other words, we were consciously seeking to bring the history of mathematics, history of American mathematics, out of the ghetto that Ivor had identified. So, in the course of our work, we introduced a periodization, which was by no means totally new with us, that seemed both meaningful and potent as an analytical tool. We argued that 4 reasonably distinct and well-defined periods had shaped mathematics in the US, specifically the 100 years from 1776 to 1876, during which mathematics developed not separately, but within the context of the general structure building of American science, as opposed to the structure building of colonial science as a whole. Mathematics was just part of that, and it was actually a minor part of that, but it was within that context. Second, the quarter century from 1876 to 1900, which witnessed, we argued, the emergence of a true research community. The third, the first third of the 20th century, during which the institutions and research traditions largely established in the previous era consolidated and grew, and the period from 1933 to roughly 1960, which saw the massive influx of European mathematicians beginning in the mid-1930s, the development of various areas of applied mathematics, and the institutionalization of large-scale government funding of basic research, both during and after World War II. So we hoped, anyway, that this framework would at least serve to establish some sort of a historiographical scaffolding on which to craft future research questions. So I'm going to leave as an analysis of the extent to which we succeeded in that to future assessors of the historiography of American mathematics. So as was the case with David and me, the essay on Women in American Mathematics, A Century of Contributions, that Judy Green and Jean Leduc contributed to the Centennial volumes, also grew into a book. By 2009, their exhaustive bibliographical study of pioneering women in American mathematics, the pre-1940 PhDs, had opened up new vistas onto the lives and careers of women mathematicians and had done much to adjust and better balance the view of the American mathematical research community of the first half of the 20th century. Similarly, although it can't be said to have had a direct influence on mathematician Scott Williams, the third AMS Centennial volume contained an essay by another mathematician, James Donaldson, on Black mathematicians in America. By 1997, Williams had begun populating a new website, Mathematicians of the African Diaspora, that, like Donaldson's article, although much more thoroughly and comprehensively, sought to make known African American mathematicians, their biographies, and their accomplishments. Williams updated the site until his retirement in 2006, but it continues on in a new guise with the support of the National Association of Mathematicians and the Educational Advancement Foundation. Like Green and LeDuc's work, it served and serves to bring to light another traditionally underrepresented group within American mathematics. Yet another group, mathematical emigres to the American mathematical community, also received coverage in the AMS Centennial volumes. Although two articles, one by historian of American science, Nathan Reingold, and one by mathematical emigre, Lippmann Beers, as well as what Solomon Lefschetz termed the reminiscences of a mathematical immigrant in the US, appeared in volume 1, it would only be in 2009 that the topic, at least relative to Germany in the 1930s and 1940s, would receive a definitive treatment in English. In that year, Princeton University Press published Reinhard Sigmund Schulze's archivally driven Mathematicians Fleeing from Nazi Germany, Individual Fates and Global Impact, a volume based on his earlier 1998 book in German. Admittedly, these are his words, unconventional in its structure, Reinhardt's book is divided into chapters, each of which considers a particular aspect of emigration, and each of which is then divided into the three parts of analysis, documentation, and case studies. The analysis sections lay out the components of his historical argument for each chapter's theme. The documentation sections then give much of the documentary evidence on which the historical argument is based. Finally, the case studies bring it all the more fully to life by incorporating accounts of the experiences of the historical actors themselves. The whole book then closes with a series of 14 appendices, most of which provide translations of documents key to the analyses that precede them. With his strong emphasis on archival findings, Reinhardt thus provided a needed corrective to much of the then existing literature on his subject, a literature that he rightly characterized as, quote, predominantly popular or anecdotal. So these four projects then represented four explicit desiderata, CUNY, in the historiography of American mathematics that were already clearly in evidence by the end of the 1980s. Two of them, the book by Green and LeDuc and Williams's website, fall under the classical theme of biography. The other two reflect the newer area of the cultural history of American mathematics, while incorporating, in the case of Reinhardt's book, elements of the classic biographical and institutional themes, and in the case of my book with David, elements of those same themes together with the technical. As the last two examples suggest, the historiographical lines that might have been drawn prior to the 1990s became blurred in a changing historiographical landscape. Okay, now, leaving the technical history of American mathematical developments aside for the moment, the classical theme that has perhaps remained the most classic over the more than 3 decades since 1990 has been biography. Despite its waning and waxing within other fields of the history of science, not to mention of history more generally, biography has continued to attract historians interested in American mathematics since it tends to be accessible to a relatively wide audience and can give a glimpse into both the mathematical mind and the mathematical endeavor without necessarily going into mathematical detail. Constance Reed's The Search for E.T. Bell and Robert Parker's R.L. Moore, these were both published by the Mathematical Association of America. Both of these aimed at a broad mathematical audience, with the former written almost like a detective story, and the latter drawing heavily from remembrances and anecdotes recounted by the students and students of Moore. Neither dealt, other than in passing, with the actual mathematics done by their subjects. Similarly, a number of other books have illuminated the lives of major American mathematicians. So here are just a couple. Carol Perique's 1991 biography, The Unreal Life of Oscar Zariski, and Genius at Play, The Curious Mind of John Horton Conway, which was written by Canadian journalist and self-styled historian of mathematics, Siobhan Roberts, and published in 2015.
In Cambridge, it's very funny to see you called American.
Yes, right, well, true enough, but nevertheless, we'll take our mathematicians where we can get them. So, aimed at an even larger audience, though, Sylvia Nasser's 1998 biography of John Nash, A Beautiful Mind, was made into an Academy Award-winning movie of the same name starring Russell Crowe in 2001 and was seen by hundreds of thousands worldwide. So if these and other biographies of American mathematicians that could have been named have targeted more popular audiences, Joe Dobbins' 1995 biography, Abraham Robinson, The Creation of Non-Standard Analysis, A Personal and Mathematical Odyssey, exemplifies the scholarly mathematical biography that intertwines the technical mathematical, the philosophical, and the geopolitical into the story of an extraordinary life. Robinson lived from 1918 until his premature death at the age of 55 in 1974. Joe thus had a number of advantages as a biographer. He was able to interview many of Robinson's colleagues, students, and friends. He had the full cooperation of Robinson's wife, Renee. He had an archive at his disposal at Yale University, which was Robinson's final academic home, that consisted of 17 boxes and contained, as Joe described it, Robinson's collected writings, correspondence, papers, and various miscellanea. So while more popular biographies of mathematicians, like those of Reed, Parker, Perique, Roberts, and Nasser, are certainly welcome, it's the kind of biography that Joe wrote that makes, in my view at least, the most valuable contribution to the historiography of the history of American mathematics. At any rate, as even this short list makes manifest, biography does not represent a lacuna in the history of American mathematics. Okay, so just like biography has continued to develop over the last 3 decades, so too has the previously well-defined specialty of the history of 20th century American mathematics to 1950. Focusing on the Rockefeller Foundation, an American philanthropy with roots in the closing decade of the 19th century, Reinhardt again cast a wide net in his 2001 book, Rockefeller and the Internationalization of Mathematics Between the Two World Wars. His was not strictly a story about the development of mathematics in the United States, although that was certainly a big part of it. Rather, it was an analysis based on the extensive archival holdings of the Rockefeller Foundation and elsewhere of the role that the foundation played through fellowships granted by both its General Education Board and its International Education Board in strengthening American mathematics at the same time that it helped to transform mathematics into an international endeavor. As Reinhardt put it, all facts point to an increasing, politically enforced independence of American mathematics from Europe in the 1930s, with the continuation of the initial IEB fellowship programs reflective of both the rise of American mathematics and, in particular, the decline of traditional German mathematics. These interwar developments took place at a historical moment in which the American mathematical research community was undergoing key changes that allowed it to capitalize on the Rockefeller Foundation's investments as well as on much else. Those are precisely the changes that I analyzed in my 2002 book, The New Era in American Mathematics, 1920 to 1950. In a sense, a sequel to the earlier book with David, The New Era is divided into 3 parts, roughly 1 per decade, that highlight what may be seen as the key components of the transformation of the American mathematical research community from a developing national community into arguably the international leader in the field. In part 1, on the 1920s, these components were the building of the infrastructure for mathematical research and American efforts to break onto the international scene. By the 1930s, they were the Depression and the influx of mathematical emigres on American mathematics. Finally, the 1940s witnessed the community first at war and then painstakingly adjusting to new political realities in the post-war United States. And the book tracks the technical mathematical developments in each of these 3 decades, as well as shifts in research foci, changing personnel, and the geographical dispersion of programs supportive of mathematics at the research level. The book's argument, moreover, calls for a refinement of the earlier periodization of American mathematics that David and I proposed back in 1994. While an American mathematical research community had emerged by 1900, and while the years from 1900 to 1920 might indeed be termed a period of consolidation and growth, those from 1920 to 1950 were distinct from it in representing a new era in which the American mathematical research community emerged as a major player on the international mathematical stage. So, although much more could certainly be done on the history of American mathematics to 1950, these 2 books went far, I would argue, to fill gaps that could have been seen, lacunae that could have been identified prior to the AMS's centennial volumes. So if Reinhardt and I work to fill gaps in the collective understanding of American mathematics up to 1950, others have begun moving into the newer areas of the cultural history of American mathematics and the history of American mathematics after 1950. So let me give you 3 examples, which I hope will suffice to at least give a flavor of these new areas and a sense of the work being done in them at present. In his 2020 book, Performing Math, A History of Communication and Anxiety in the American Mathematics Classroom, Andy Fiss takes a cultural historical approach excuse me, in presenting mathematics education in 19th century America in a new light. Prior scholarship, as I mentioned, had focused on questions like what was taught, how was it taught, that is, on the subject matter, on the professors, and on the textbook writers. Fiss doesn't ignore those matters, but he poses different cultural historical questions. How did students learn in the classroom? What was their actual classroom experience? What exactly did they take away from their studies? His focus is thus on the students and their in and out of class experiences, and he succeeds in giving his readers a vivid glimpse into 19th century mathematics education from their perspective. In short, he shows how they performed. They read aloud from their textbooks. They marched around their respective college towns, participating in elaborate burial ceremonies of their mathematics textbooks. Literally, they dug holes and buried them. They were called to write out and explain solutions at the blackboard. They staged plays in which they mocked but also celebrated their mathematical educations. They were made, in short, to participate in public oral examinations. They performed. So whereas Andy's research turned to look at the history of 19th century American mathematics through a new historiographical lens, thereby addressing what in an ever-changing historiographical climate had become a lacuna, the next 2 books move beyond 1950 Christopher Phillips's 2015 study, The New Math, A Political History, preceded Fiss's book in taking mathematics education as its point of departure. Whereas Alma Steingart's 2023 book, Axiomatics, Mathematical Thought and High Modernism, utilizes the cultural historical approach to argue how the changing mathematical conceptualization of axiomatization influenced a broad swath of American post-war culture. The United States of Phillips's and Steingart's works is one characterized by Cold War angst and its myriad effects. In Phillips's case, those effects were political, in especially the post-Sputnik era on mathematics education. In Steingart's, they were cultural in the form of high modernism, that is, what she describes as the sweeping vision of how the benefits of technical and scientific progress might be applied, usually through the state, in every field of human activity. So while both of these valuable and enlightening studies serve fundamentally to illuminate the history of American mathematics after 1950, they both underscore, in the context of the historiography of American mathematics that I hope I've been laying out here, what I would propose is the main lacuna, so we finally get to my sort of answer to this question, in the sense of deficiency as opposed to total absence in that history, namely its technical development. So I make this statement with some trepidation. At its heart lies the problem of audience. We were also asked to consider the problems in filling these lacunae, so here they come. For whom are we, as historians of mathematics in general, and as historians of American mathematics in particular, writing? Clearly, we're writing for each other, since it's with each other that we are, or should be, sharing a literature and historiographical commitments. We also hope, though, depending on our topics, to be writing for a broader audience of historians of science, of historians, of mathematicians, of others. So the three books I just mentioned by Fiss, Phillips, and Steingart do just that, but none of them can be construed as technical. Steingart, however, does open her book with a chapter in which she gives a nice sense, from a largely philosophical point of view, of the evolution of abstraction in a mathematical context by focusing on Norman Steenrod's education and career in topology. With a touch light enough, hopefully, and she says this, hopefully, not to intimidate a non-mathematical audience, she traces how Steenrod was enthralled as an undergraduate by axiomatically driven point set topology before encountering and eventually being won over by, as a graduate student, the other topology that is combinatorial, or what we would call algebraic topology. Steingart next charts how algebraic topology changed as mathematicians like Steenrod and Samuel Eilenberg, among others, restructured, in her words, what it fundamentally was. They changed what algebraic topology fundamentally was. As she put it, quote, instead of introducing readers to concepts such as complexes, oriented complexes, and chains, which were rooted in geometrical ideas, Steenrod and Eilenberg presented the axioms first and then derived these concepts from them. In so doing, they reversed conceptual priorities. And as she shows, this high modernist process of restructuring went hand in hand with a striving for universality and unification, as exemplified in the category theory later formulated by Eilenberg and Saunders MacLean. The very important interpretation within the framework of high modernism aside, this is material already familiar to almost all mathematicians. But what about tracing the historical development in the United States of some aspects of mathematics that thrived between, say, 1900 and 2000? What challenges would the historian face? This was another one of our questions that we were supposed to address. So perhaps first and foremost, would be the challenge of the technical difficulty of the mathematics itself. I mean, a no-brainer. It would likely require a PhD in mathematics in addition to a PhD or at minimum an MA in the history of science. And in today's academic climate, at least in the United States, one in which graduate programs have shrunken and pressures to decrease time to degree have increased, that level of credentialing seems completely unrealistic. And even if it were feasible, while it would prepare the historian to tackle the question, once answered in dissertation form, to what sort of career might it lead? Perhaps one in a liberal-minded mathematics department, but not likely one in a history department, or even in one of the decreasing number of history of science departments. So, do we have the makings of what Ivor characterized as a ghetto subject? If we're thinking about American mathematics technically from 1900 to 2000? One way out of this would be teaming up with a historian of mathematics and a mathematician, and with the latter responsible primarily for the mathematical content of the historical argument, and the historian responsible primarily for formulating the historical questions and contextualizing the whole. Achieving such a collaboration across the disciplinary boundaries of the history of science and mathematics, though, wouldn't be too easy. Still, as the current collaboration of Volker Remmert and Rebecca Waldecker on the history of the classification of the finite simple groups attests, it wouldn't be impossible. It would also provide the antidote for the kind of historiographically uninformed, if mathematically highly informed, mathematical history that they championed. So, assuming that the problems of mathematical and historical expertise are solved, however, doing the technical history of American mathematics after 1950 also faces the challenges of sources. The printed sources are certainly there, but whereas historians of, say, American mathematics before 1950 can go to myriad archival repositories to dig more deeply into the historical record, what does an archive look like in the computer age? Correspondence means, among other things, electronic emails, not letters penned or typed and carefully housed in archival collections. Drafts mean, if one's lucky and computer files haven't simply been overwritten, computer files generated on machines and in formats that may or may no longer exist. Perhaps a concerted effort to interview mathematicians like the Princeton Mathematics Department's Oral History Project of the 1980s could help preserve something of what's invariably being lost. Admittedly, though, that would be a big undertaking and one difficult to fund. And there is that problem of audience. To write the technical history of American mathematics after 1950, almost by definition, would limit the audience to mathematicians. Are mathematicians interested? Or would this risk being a literature without an audience now? Would it risk finding its audience only 50 or 100 years from now? Who knows? What this question of audience suggests, though, is the desirability of greater dialogue between historians of mathematics and mathematicians. Maybe we, as historians of mathematics, have actually to prime our audience of mathematicians by convincing it that the questions we're asking and answering and the approaches we are trained to take are ultimately more illuminating than the mathematical history that they espoused. If that's so, then, as Jeremy said in his focus piece in ISIS, we have a lot to do. So let me conclude by making 3 points. First, there are many lacunae or deficiencies in the history of American mathematics. Thinking just about the period from 1920 to 1950, I can think of dozens of directions into which interested researchers could go, like the project that Della Dunbar and her collaborators are pursuing on the life and work of Oswald Veblen, and about which we just had a wonderful 2-week-long workshop here at the INI. In this workshop, though, this week, we were asked to make an argument for what we consider to be the most important lacuna in our respective subfields. Second, the isolation of the technical history of American mathematics after 1950 as a deficiency is by no means unique to American mathematics and its history. It's a deficiency in the history of mathematics, full stop. To be sure, mathematical history in Wei's sense has been done and can be useful to both mathematicians and historians. But as should be clear, the lacuna I hope I've identified concerns analyses from a more historically sensitive point of view. Nor should this lacuna be unsurprising. In fact, isn't it obvious why it should be the case? The mathematicians who are doing that kind of mathematical history don't know how to ask that kind of question. So third, and to conclude, I want to paraphrase Armand Borel, a major figure in American mathematics in the period after 1950 and until his death in 2003. I feel that what the history of American mathematics needs least are pundits who issue prescriptions or guidelines for presumably less enlightened mortals. Let each historian follow his, her, their own interests and hearts, and the field will be the richer for it. Thank you.
We've got 3 minutes and 35 seconds for questions.
Sorry.
Sloan.
Peter, thank you for a very stimulating talk. So give us some hope. So you said possibly our audience could be in the future,
Right.
50 to 100 years.
Right.
In your historiography, do you have a sense that that history of math written 50 to 100 years ago is now just being appreciated?
I think that there are some examples of that, which is why I suggested that this could be, I suggested, I think, that this is a reason why we should try to do it now while we still have some contact with it. But, you know, that's not maybe so practical. I'm not trying to say that there's no hope here. I'm just saying, because we were asked to isolate the problems with the lacuna we identified, I see it as a problem. I mean, if nobody can really read say you're in a history department and you do one of these studies, your history colleagues are not really going to appreciate it when you come up for tenure. So there needs to be different ways of handling this. I don't know, did that address your question? Okay.
Troy?
No, you had your hand up before me, I'm sure.
Oh, I saw your hand. I'm trying to go front, back, so it's not all people in front of us that ask questions.
All right, okay, fine, sorry. So you suggested that one of the challenges here is the technical difficulty of the mathematics, which I'm not denying. But something that I've thought a few times is, presumably in, say, Isaac Newton's day, he felt his mathematics was very difficult indeed, and yet we now learn it at secondary school.
Right.
So, is it the case really that mathematics is just getting harder and harder and harder and harder and harder? Or will this kind of work that you're talking about be not too difficult in a couple of 100 years?
I absolutely think that will be the case. But if we don't kind of capture the moment, what are they going to draw on in trying to get their history? See, in the case of Newton, we have all of his papers, and many more of them were discovered. But you know, a lot of this isn't even on paper. At least what we as historians need to kind of sink our teeth into. So, no, exactly. Obviously, Newton's work was really advanced for the day, and nobody really appreciated it. Few people appreciated it at the time. And that's certainly the case, I think, with a lot of what's going on now. Or the number of people who appreciate it are the 5 people in the world who work in that little area.
Yeah, thank you, Karen. Can I just suggest add to the audience?
Absolutely.
So I think students, master students, that's, and actually also bachelor students. So that's my experience from Yale University. I'm in the math department, and we do attract students, and not only students who are going to be high school students, also students who want to pursue a career as research mathematicians in our history of math courses. And that could also generate a collaboration
Yep.
with mathematicians.
Right.
Because I think you're quite right about these things that we need to cooperate.
Yep.
But one way into that could be through maybe students and teaching.
I totally agree, but as you probably noticed, I was focusing, and I was kind of careful to say, at least in the United States. I mean, graduate education in the United States has become difficult. And programs like yours, which there used to be at the University of Virginia, don't exist anymore, where exactly that kind of training could happen. So, you know, it's economic pressures, but thankfully, like in Denmark, it's not happening everywhere, or in France for that matter.
There were hands up all over the room, and time is already beyond the 0 point. So I know there's going to be a lot of discussion out there when you can pigeonhole Karen, and this discussion that she's so beautifully outlined for what lies ahead is obviously going to continue for some time. So please, all of you that had your hands up, be sure to speak to Karen directly. She'll be talking for the rest of the week, I think, but at least in conversations directly with you. So thank you again, Karen.